Okay, thank you everybody. It's really a privilege to spend the next 50 to 60 minutes with you talking about ways that you can leverage AWS and the platform that Amazon Web Services provides to enable DevOps as a practice within your IT organizations, and also look at continuous integration and deployments on top of the AWS platform that you're building. So today we're going to be talking about DevOps, of course, but the focus will very much be on continuous integration and delivery or deployment of your applications. Okay, if there are three main business drivers that we typically see organizations looking for answers to, and looking particularly to AWS to help provide solutions around, it is they want to accelerate these three dimensions across all of their development lifecycle and also deployment of their applications internally as well. So today we're going to spend quite a bit of time focusing on these three things. These are the core drivers that we'll be coming back to throughout the rest of the hour. And so what we'll be discussing is how DevOps and continuous integration and deployment can help drive innovation internally in your IT organizations. And we'll talk about the mechanisms that it puts in place to remove or reduce risk for change and encourage experimentation across your development teams. We'll also be looking at the gates and the checks and the balances that such an automation approach provides, and that will directly lead to hopefully improving the quality of the software that we build and deliver for our customers. So there's a very important quality dimension to this, but also a topic that's particularly interesting to our largest customers in the enterprise is how can they get and build a governance model around the change that they are enacting on AWS. In a world where it's very simple and straightforward to automate provisioning servers and potentially quite complex environments, how can they build that governance framework? And I think continuous integration and deployment provides a compelling model to help do that as well. So let's refresh and have a look at what a continuous integration and deployment workflow typically looks like. At the heart of this workflow, right in the middle of this diagram, you see CI/CD tool. And this is the engine room of this workflow. This is where the decision making happens, and this is where all the other orchestration happens, and is a very large part of what we'll be focusing on today. But the actors and the agents in the system are on the left-hand side of the diagram here. And these are typically business owners, development leads, and of course developers. And what they are doing is registering work to be done in an issue tracker of some sort. These might be bugs that need to be fixed in an application, or they may be feature requests for brand new features on an application. But the issue tracker is holding that work to be done. And developers are picking tasks from that, or being assigned tasks from that list, and contributing code and changes to application source code into their source code management system. Then the CI/CD tool can pull from the source code management system and can call out to automated test harnesses. And we'll talk about different ways of automating tests today. We'll go through some concrete examples there as well. This is really important that we want to try and remove human error and improve consistency for how we're testing our application changes. And finally, of course, we need to enact that change in a target environment. And so a large part of the final part of the presentation today will be about deployment and automation approaches on top of AWS, with the end goal, of course, being deploying our application. But we wanted to make today more concrete. Rather than just talk about theory, we wanted to give you some concrete examples of tool chains that you can go away and start looking at and using. And we'll even demo some of these today and step you through some of these concrete tool chains. So the main one we'll be looking at today is Atlassian Bamboo as the CI environment. It is also playing the role of automation for continuous delivery as well. And we've represented another plugin for Bamboo here called Tasks for AWS. And this is one of the differentiators of Bamboo as a CI platform, is that it can be extended easily through a plugin architecture and plugins available on the Atlassian marketplace. And Tasks for AWS is one such plugin. And the reason we're talking about Tasks for AWS is it gives Bamboo a much richer insight into AWS. It enables integrations directly against automation tools like CloudFormation, application hosting services like Elastic Beanstalk. It can even integrate against EC2 natively, the virtual server platform that AWS makes available, and can do a whole range of tasks for us without us having to do that integration work ourselves. So it gives Bamboo more insight, but it also makes our job easier when we're building our continuous integration pipelines. So let's set the scene and talk about a pipeline. and this is really a pipeline that traces the life cycle of the application artifact that we're going to be building and deploying and moving through environments. So we've represented 5 stages to the pipeline here. The first is code, and this is where we're contributing code to our source code management system and making changes and bug fixes and potentially branching for new features. We'll cover that in quite some detail. The next stage after that is test, and this is the first gate. This is where we run automated tests over a code change in the previous stage. And if this test stage fails, the entire pipeline is halted. So we don't continue through the pipeline unless we get a green result out of test. Following that, we have a deploy stage. And what we're talking about here when we say deploy is bundling up an artifact for deployment. We're not talking about moving that artifact into an environment. We're talking purely about building an artifact, bundling it up for deployment. The next stage is release, and this is where we make that change in the target environment. And we'll talk about different models for releasing today, and we'll focus primarily on the discrete environment model where we stand up a brand new environment for an artifact and deploy to that. And then finally, to complete the pipeline, and remember this is a life cycle, to complete the life cycle, we have the teardown stage, and this is where we do things like potentially clean up after ourselves, after artifact generation, after creating new environments, potentially tearing down old environments depending on our release methodology and so on. So code, test, deploy, release, teardown is the high-level pipeline that we'll be talking about, and we'll see this represented in our demo later on. The first stage around code has a number of things we need to think about, and the first thing is how do we manage our source code in our source code management system? How do we, what model are we using to manage this? So what I've represented here is a model that we see and is quite prevalent in the industry, and it's a model that's called feature branching. Okay, so what feature branching is all about is encouraging your development teams to branch early and often, and probably using a source code management system where branching is effective and cheap and easy to do, because we'll be branching often. And what we're representing here, apart from just having feature branches, is that every single commit in every single branch is going to run our complete pipeline. And this is important. We'll come back to this again, but this gives us a consistent pipeline that we run over every single change. So that's the first point. And the other point here around feature branching is that we can contain the risk of change within the branching model. So when we branch for a new feature, we can do work in that branch with impunity without the risk of impacting other changes that are currently in flight, and we can do that in isolation, and that actually frees up our development teams to try things and experiment. One of the challenges that comes with the feature branching model, especially in large environments with lots of work in flight and parallel features in flight, is that we can end up with lots of concurrent feature branches or feature branches in parallel. And so what we're talking about here is a mechanism to help reduce that complexity. And so what I've represented here is 2 feature branches, both branched off the same parent branch, where we could potentially be making changes that conflict with each other. So feature 1 and feature 2 are both being made to the same code base, potentially on the same assets that could conflict. And in a normal model, what we would do is when we were finished with feature 1, we would merge that back into the upstream branch, and then when we'd finished with feature 2, we'd merge that back up into the upstream branch, and we'd realize a conflict there. And now if this was a high priority branch, or a higher order branch, something like master or perhaps trunk, that may represent our production environment, we're introducing a degree of risk there if we're capturing the conflict there and having to manage it. So one approach is to use something called automated merging, and I've got a screenshot here which is a widget in Atlassian Bamboo, in fact, where you can enable this and automate this. And what automated merging is going to do is once we've finished with our feature 1 change and we've merged that back into an upstream branch, what Bamboo will do is take that change and merge it downstream into all the other downstream branches. So in our case, it will merge it into the feature 2 branch. Now what's the difference here? Well, we're now capturing the conflict in the feature 2 branch. It's well away from a higher order branch that we care about. It's nowhere near master or trunk. It's nowhere near production. And it's a place where we can manage the conflict safely, again, using the branching model to isolate our change so that we're not trampling on other work that's in flight. So this is an important idea where we're leveraging feature branching and isolation, but also managing complexity of multiple feature branches through automated merging. So let's have a think about what CI is really trying to give us, continuous integration is trying to give us. The first point to make is that we're always pushing changes through a test stage. So we're never promoting anything without that change being tested thoroughly. And if we're automating our tests, we're doing that in a consistent way. We're also trying to fail fast. So during our continuous integration pipeline, we're trying to get feedback as quickly as possible. And so it's important for our tests to run quickly and for that feedback to be propagated back to the owner of that change quickly as well. And this lets us then iterate quickly and pivot and try new ideas and bug fix and what have you. We're also trying to reduce risk of change. Remember, we talked about the branching model to contain that risk. And by failing fast and running tests on every single commit, we're trying to detect bugs really quickly as well. And we're trying to find them before they even get to a test environment. And of course, we're automating tests largely so that we can reduce test effort, human test effort particularly. Okay. So let's have a look at a pipeline. I have an example here in Bamboo, so I'll just switch to my browser. Now, hopefully you can all see the Bamboo interface here. So this is Atlassian Bamboo, where I've already built a project, and I have two different plans or pipelines. Bamboo calls a pipeline a plan or build plan. I have a web application pipeline, and I have a data sources pipeline. I'm not going to go through the user interface so much here. It's not that important. I will call out, though, that we have different build numbers here and that both my builds are green, which is important. So in other words, I've had successful builds. You can see that I haven't done a lot of work with my data sources pipeline. I haven't run that for several months, and we'll go through why that is the case. But also, you'll notice that my web application pipeline ran just 11 minutes ago, and we'll step through that as well. I'll call out here a nice feature of Bamboo next to the web application pipeline. We are using something called plan branching here, which enables us to automatically build new plans for new branches that we've created in our source code management system. So if we're really embracing feature branching, we're branching early and often, this means in Bamboo we only need to define one plan, one build plan or one pipeline that we can run consistently over every single branch, and Bamboo will automatically find those new branches and branch our plan as well and run our plan automatically. So this is a really nice feature that Bamboo provides that many other CI environments don't give you. But let's go into our web application pipeline itself, and I've already opened this in another tab. And look on the left-hand side here, we have a number of stages and jobs within each stage. Now, if you reflect on the 5 stages we mentioned earlier, code, test, deploy, release, and teardown, you'll see something that mirrors that quite closely here. We have a test stage, a build, a deploy, and a teardown stage. And within each stage we have jobs. So let's have a look at the test job, or sorry, the unit test job inside the test stage. And what Bamboo is showing us here is the output of a unit test harness that has been run over a code change that I've just pushed through 11 minutes ago, or actually 27 minutes ago, I should say. Bamboo gives us output, so we can see successful tests, we can see the logs for our tests. In this case, it's just showing me that I've run 5 unit tests, so these are fairly synthetic, just to give you an idea of how you would integrate this. And this is how you would pull together a really simple unit test harness and automate that. And so what Bamboo is doing here is it's watching a source code management system. In this case, I'm using GitHub. I've configured my plan to look at the GitHub repository. It's checked out the code from GitHub and the change, and it's run the test harness over that change locally on the Bamboo server and given me a result. Now, if this had failed, you would see a red stage here, and the entire pipeline would have stopped. What I'll also do is I'll go through just really quickly from the pipeline how I've configured that, just to give you an idea of the actual implementation. So here we have 5 stages, the unit test job that we just had a look at. If I load that, we'll be able to see the way that we've called out to our test harness. Just bear with me while the interface loads here. Okay, so within the unit test job, we have a source code checkout, which is responsible for integrating with my GitHub repository that the plan knows about, and then it's run a command task, which is my application test harness that I've built for my Python application. So this is a web application that I've built prior to this. And so it could be as simple as that, or it may be more sophisticated. In this case, we're using some Python test harness or test libraries here. You can imagine all sorts of other tests that you might run here. You may look at a security audit test, or you might look at a load test here. There's a bunch of other options, but I'm just demoing unit test. So this is, at its simplest, what a CI pipeline does. It just checks out code out of a source code management system and runs unit tests over it and gives you a pass or a fail. Okay, the most complex part of deploying an application, of course, isn't checking source code out and running unit tests. It's actually how do you manage interruption and deploy that change to an environment, potentially a production environment with live traffic on it. So we're going to focus for the rest of the session on continuous deployment and delivery. And so before we actually dive into how we achieve continuous delivery and deployment for our apps on AWS, we're going to dream up a wish list of the things that we want CD to give us. So what we have here is a list where the first of those is we want to be able to push changes quickly to a target environment, and we want to treat target environments just like any other environment. We don't want to treat production especially from UAT or pilot or sit or test or integration. We'd love a consistent deployment approach that treats every environment equally. We want CD or continuous deployment to give us a mechanism to get feedback from users immediately and quickly. And we also would love CD to support the notion of having multiple versions of our application in production at any one time. And so this lets us potentially do things like A/B testing, where we can test our customers' reactions to new features that we're deploying. And we can run analytics over a new version of our application to gauge whether or not that change is effective and then feed that back into our development lifecycle. So that's an important thing that we'd like CD to give us. We'd also like this to be a tested and repeatable process so that we've de-risked the deployment process. And this goes back to my earlier point about not treating a target environment specially. We'd love for continuous deployment to be completely unsurprising and just routine. And of course, by being able to do lots of deployments and potentially leverage things like analytic tools across multiple versions of our application, we can get a breadth of data points about our application, about the performance of our application, but also about the effectiveness of a change and how our customers are interacting with it. So it's quite a big list of things that we want C to give us, so let's think about how we can achieve that. There are a number of different ways of hosting your deployment or hosting your application in AWS and particularly managing the deployment of the change. And so today we're going to focus on the one on the right here, CloudFormation, almost exclusively, because it actually gives us the most flexibility. But there are a number of other options that are available to us on AWS that give us a degree of convenience and takes a degree of flexibility away. So if we look at Elastic Beanstalk on the left, that is an option for you to just have a hosted container managed by the service, by Beanstalk as a service, where you just deploy your application bundle. You don't think about load balancing, multi-availability zone architectures. You don't think about bootstrapping a Tomcat or a Rails container that is provided by Beanstalk for you. You focus purely on your application, developing your application and features, and then hand that off to Beanstalk to host. At the highest level, that is effectively what Beanstalk is doing for you. But the trade-off there is that you can't control the application architecture. So Beanstalk provides a convenient way to do a two-tier architecture, a load balancer with an auto-scaling group of application containers behind it, and optionally a relational database as well. But that is as sophisticated as Beanstalk will allow your application architecture to get. If you need more sophisticated application control, OpsWorks gives you that. So OpsWorks uses Chef as a DevOps toolchain to bootstrap your servers and define the role that servers play within your application architecture. What it also lets you do is define layers within your application architecture as well. So rather than just having 2 or 3 tier architectures, Opsworks lets you build n-tier, where each tier is defined using chef recipes. Okay, and so we're able to leverage a standard, very frequently and widely used DevOps toolchain to do that bootstrapping and customization work. Code Deploy is a new service that we released and announced at reInvent last year, and is slowly being released to more and more AWS regions around the world. And what Code Deploy tries to do is take the complexity of the deployment process off your hands. And we'll talk through how complex that workflow can be in later slides. But what Code Deploy does is take your application artifact and allow you to configure rules for how that artifact is rolled out across a fleet of servers, and gives you hooks into that deployment process to do work, to do custom work. So you can have a pre-deployment hook that lets you do some preparation work on a server before an application is changes deployed, and you have some post-deployment hooks as well that lets you do cleanup. So it's purely around the deployment process. CloudFormation, on the other hand, is a very powerful and flexible automation tool that understands AWS services really well, and in fact can be used to not only stand up your AWS infrastructure and manage changes to that, but also deploy your applications. And in fact, today we'll talk about how we're doing application deployments and also database schema changes via CloudFormation. And we're going to start talking about some more advanced ideas around how we extend CloudFormation to do things that it doesn't natively support. There are 2 main deployment approaches that we'll talk about or raise, and we'll spend most of the time talking about discrete environments, but it would be remiss of us not to talk about deploy in place, because it is relevant and it is an important deployment strategy. So what we mean by deploy in place is the process of reaching into a running server and deploying an application change or an artifact. And in the case of a fleet of servers behind a load balancer, we need to carefully manage interruption. So what we might do is we might break the connection between the load balancer and the back-end host. We might use connection draining to gracefully break that connection, so we're not interrupting in-flight requests or sessions. And then we might reach into that host, deploy our change, sanity check it, make sure that we're okay with the change, and then re-enable the connection to the load balancer, and then roll that process out across all of the servers in that tier. And so there's actually a somewhat sophisticated workflow happening behind the scenes here, and you also need to think carefully not only about managing interruption, but also managing rollback. So the rollback process in this environment, or this mechanism rather, becomes a little more complex, and you need to make decisions about whether you roll out server by server or roll out to the entire tier at once, and so on. The other approach, which is quite different and is enabled through automation approaches on AWS like CloudFormation, is to stand up a completely new environment, and we call that a discrete environment, and we deploy our artifact to that environment. So we then have effectively two discrete isolated environments running 2 different versions of our application. And we'll go through this in quite a bit of detail, but this gives us the flexibility to do things like A/B testing. Roll forward, roll back is a lot more robust, and we can also support multiple releases from multiple branches and concurrent work much more easily. Let's look a little bit at Code Deploy. And Code Deploy, as I mentioned briefly, is all about automating the deployment process. It helps manage and minimize interruption to your applications. It gives you a centralized place to control how that deployment process occurs, and it has some really nice integrations with some of the other tool chains on the market, source code management systems, and also continuous integration tool chains as well. So Code Deploy can support auto-scaling, and through a mechanism that allows you to define a deployment group, makes it a consistent and repeatable deployment process as well. One of the heuristics that Code Deploy exposes is how quickly a deployment occurs, and it does that in terms of how the change is rolled out across hosts. And so some of the heuristics that we've built into the product are deploying to a host 1 at a time, deploying to half of the deployment group at a time, and also deploying to the entire deployment group at once, okay, or all at once. And so you can see here that we're able to define different heuristics to manage the interruption. Obviously, if we're deploying to all the hosts at once, we could be interrupting our service. So where that's important, we may choose to deploy half of the time. If we can't afford to take half of our infrastructure footprint out during a deployment, we may choose to deploy fewer servers at a time, and so we can define custom deploy speeds as well. So this is the kind of mechanism that CodeDeploy makes available to manage interruption. Some of the product integrations that we see are around the CI environments. So we have product integrations with GitHub and Atlassian. You can see Jenkins and Circle CI and all the usual suspects there. There are some nice integrations with those tool chains to call out to CodeDeploy. It's also really important to mention that you can reuse your existing scripts. Okay, so a lot of us have built scripts that encode business logic around how we deploy our apps, and these might be shell scripts or PowerShell scripts, or we might even be leveraging a DevOps environment like, or a DevOps toolchain like Puppet or Chef. These are able to be reused in those deployment lifecycle hooks that I mentioned earlier, so that you can continue using those same processes. So we can reuse that IP if you like. So I guess one of the more popular ways of deploying a change is to take advantage of the fact that it's really easy to bake your change into an Amazon machine image. And so one of the common approaches is to use AMI baking to wrap up your change within the AMI and then use your AMI as the artifact to deploy your change. So rather than creating a zip or a tarball or some other kind of archive, maybe a web application archive for a Java Enterprise Edition container, we basically bootstrap a host with our application change and snapshot that in a server image or an AMI. And so what we've called out here is a simple process that we can follow to automate that. And we start a builder instance, and this is just an EC2 instance that uses our standard operating environment. We might choose a Amazon Linux AMI, or we might choose a Windows Server 2012 AMI, but we have a baseline that we start with, and that's our standard operating environment. And then what we do is we bootstrap our application on top of that. And so we use tools like CFN and Init to customize the host and bootstrap our application. This might be installing libraries, installing the application container, actually just installing our application archive or artifact inside of the container, so that we have a fully configured running host with our application on it. And then what we do is we bake our AMI, and that's nothing more than calling the EC2 create image API, which then snapshots and seals our application change within the AMI and gives us a brand new AMI with an AMI ID. We then tag that AMI, and we use that for reporting and cost remediation. And once we're done and we've created our AMI, we then terminate the builder instance. We don't need that builder instance any longer. So depending on how long that bootstrapping and baking process takes, we may only be running our builder instance for several minutes. This is an example of CloudFormation Init. So this is the bootstrapping mechanism that I spoke about. And it's a very simple example of CloudFormation Init code that installs some standard packages using a package manager called Yum. Many of you will be familiar with that if you run Linux environments. We're installing basically Apache web server here. And we're showing how CloudFormation Init can also lay down files on your file system, set permissions, change ownership, and even start services to start at boot time. So a fairly trivial example. There's, I guarantee your bootstrapping process is going to be more sophisticated and complicated than this, but CloudFormation Init can actually do a lot of that work for you, and this is what we use in our demo. So let's have a quick look at a CD pipeline. We will flick back to Bamboo again and go through the web application pipeline again first. So what we looked at before was an example run of our web application pipeline, and we looked a little bit in detail at the unit test part of that. We'll focus on the build and the deploy stages though. And so the build stage is basically where we're going to bootstrap our host, push our application change onto that host, and then snapshot the host in an Amazon machine image. The output of this will be a new AMI. And then the deploy stage is picking up that AMI and using CloudFormation to deploy a brand new discrete stack that contains our new application change. And so that new stack will reference the new AMI that we created in the previous stage. So let's go through and actually look at the implementation of that pipeline quickly. So I'll go to configure plan here and look at build AMI. So the build AMI job inside the build stage is doing a fair bit of work. Here we're checking out the source code again. We're wrapping that up into a tarball, and we're uploading our tarball to an S3 bucket. We're then using a CloudFormation stack to start a new EC2 instance purely as our instance builder. And the CloudFormation stack is using CF and Init to bootstrap our application. So it's going to pull down the S3 object application bundle out of S3 onto the host, do some other work that we've defined in the CloudFormation template using CF and Init, and then when that's complete, we'll have a running complete application server with our app change in it. We'll then take advantage of tasks for AWS, which is that plugin that I mentioned earlier, to bake our AMI. So tasks for AWS makes it trivial to snapshot a server. It has an option in the plugin to take an image of a running server, and that's all we're doing here. And then we're going to, again, using CloudFormation, because we use CloudFormation to start the instance, we'll use it to tear down the builder instance as well. And then finally, we're going to have a custom command which registers the AMI. And so what this task will do is take the AMI that was created in the EC2 image task here and take the AMI ID and push that into a DynamoDB table, which is where we're going to keep our AMI registry. And this is a way for us to look up previously built AMIs and look up the current AMI, and we'll have some associated metadata with that in the DynamoDB table. So that's the process for basically building an AMI out of a running server. Let's look at the deploy stage. So the deploy stage is just a CloudFormation stack. And what this CloudFormation stack will do is build a completely discrete environment for us and look up the AMI that was just created. It will do a lookup in the DynamoDB table, and it will use that AMI to build the new discrete environment. So we don't do any bootstrapping at environment creation time. That's all been baked into the AMI, and so our new environment starts quite quickly. The AMIs just start, and it takes several minutes for the servers to start. And so that's our CD pipeline. What we also have is another pipeline for data sources, and I'll go through this really quickly. I'm not going to spend much time today talking about it, but what we've decided to do to make this a less trivial demo or a demo environment is not just deploy stateless web applications through Bamboo, but also deploy our database and database schema changes through Bamboo as well. And so what we have here is a data sources pipeline with 3 stages in it: test, deploy, and teardown. They will look quite familiar to you. And what test is going to do is build a CloudFormation template, which is going to end up using a CloudFormation custom resource to deploy a schema to a database. And so the test phase is responsible for constructing the CloudFormation template and doing things like syntax checking it. And the deploy phase is responsible for either instantiating a new CloudFormation stack or updating an existing stack. And we'll go through this in more detail, but we're leveraging a library here in a custom resource in CloudFormation called Liquibase to manage the schema and to do those schema updates. So we're effectively using CloudFormation with Liquibase through a custom resource to manage the lifecycle of our schema as well. And we also have a teardown stage, which we would almost never run. The teardown phase here, or stage, would be responsible for actually terminating the database environment. So we make that a manual task. Actually, you may never have this in a pipeline. You might do this manually. But it's nice to model the entire lifecycle of our asset, including our database, this way. Okay, so that's at a high level what a CD pipeline looks like in Bamboo. Let's talk a little bit more about the release process. So we've talked about how we build our artifact and bake that into an AMI. The release or stage is responsible for pushing that change out to a discrete environment. So there's several steps to that. And the first is to test the new stack. And by test the new stack, I mean sanity check that our new application and discrete environment is working as expected. And remember, it's a discrete environment. It's not the existing environment, so we can do that in isolation. Once we're happy with that new discrete stack, we do something called traffic matching between the two stacks to ensure that the new environment is capable of sustaining the load that is on the current environment. We'll go through the mechanics of that, but that involves scaling up the load balancer, making sure that we have the same number of servers behind the load balancer to satisfy the current load. We then use DNS as the switch to turn on the new environment. So we use something called a floating DNS record, and we're using Route 53 because it's programmable. We can do this. We can automate this process, and we'll effectively, when we're happy with the new stack and we've matched traffic, flip across using DNS, and then we'll send a notification to a team of people to say that this change is complete. This might be our operations team, for example. And then we'll have an optional stage here, which is rollback, in case something goes awry and we need to flip back to the previous known good state. So what does that actually look like? This is a blue-green deployment approach, and so the current environment is blue, and all traffic is going through the blue stack. So we're using DNS, and DNS is resolving to our blue load balancer, and the blue load balancer is balancing traffic to 4 back-end servers running our application in the environment. What we've done through the CD process is stand up the green stack, the discrete environment. You can see it's identical apart from the number of servers behind the load balancer. And so that's why we do traffic matching. So traffic matching here might be as simple as saying, interrogating the blue load balancer and saying, how many servers do you have? You have 4. I need to make 4 green servers behind the green load balancer. It may be more sophisticated than that. We may actually generate real load based on the current load that the BlueStack environment is seeing to warm the entire environment. We have different approaches and ideas there, but at its simplest you want to say make sure that the same number of servers are available. Once we're happy with that and we've tested it, we use DNS and we flip the DNS record and we basically update that zone record to point to the new load balancer DNS name. We use an alias to do that. If we're not happy with that and we need to roll back, then we do another simple DNS update, and rollback is as complicated as that. And we know that rollback is robust here because the BlueStack was working. It was serving traffic, and we know that we can go back to it confidently until we get the green stack right. Okay, so the final stage is teardown. Teardown is important and shouldn't be forgotten. It's a really important idea to avoid CD sprawl or continuous delivery sprawl. It's very easy for us to use CloudFormation to stand up new stacks. It's really important for us to remember, once we've flipped to the green stack, to tear down the blue one when we no longer need it. But we don't just tear it down. There's a few things we do around due diligence before we do that, and one is to potentially ensure that there's no traffic moving through the load balancer. So that's something we can do programmatically, and Bamboo could even drive this. And once we're happy with that, we use CloudFormation to consistently tear down the stack. It was responsible for creating it. It knows all the dependencies, so it can tear that down cleanly. And then we could even optionally deregister the AMI once we're happy with the green stack. We don't need that AMI around anymore. Some businesses may choose to keep that AMI as an audit trail and a log of what's been deployed. That's really going to be up to you. And so teardown consists of tearing down the blue stack and only having the green stack available. And then the next deployment process rolls this. So the green stack becomes the blue, and we deploy a new green and flip across and effectively roll new versions of our application through discrete environments that way. Okay, in the remaining time, we're going to talk about some more advanced techniques for managing continuous delivery and deployment especially. So we're going to talk about how we can use CloudFormation to achieve segregation of duties and improve reuse. We're going to also talk about CloudFormation custom resources and how we can extend CloudFormation and what it is able to do. And I alluded to this earlier when I was going through our data sources pipeline, and I talked a little bit about Liquibase custom resources. So we'll talk about that in a little bit of detail. And we'll also talk about extending our CI/CD tools and making them more aware of our AWS platform. So the first idea is something we call stack chaining. And here I'm representing 3 different templates on the left. These are CloudFormation templates that are responsible for building different parts of my application environment. And so the first template here is just laying down my virtual private cloud my subnets, setting up my security groups and my network ACLs, and maybe building associated supporting infrastructure like an S3 bucket. Okay, but that's all the template does. But remember, templates can be parameterized, and they can also generate outputs. So what we can do is take the outputs of this template, namely things like the subnet IDs, the ARN or the resource name for the S3 bucket, and we can pass those as inputs to the second template. And that gives the second template context and awareness of what the first template built. We can do this with nested templates as well, or separate templates that we wire together this way. And so the second template might stand up a DynamoDB table and configure some CloudWatch monitoring, and maybe configure a backup host and a Bastion host in a public subnet. Again, we take the outputs of those two templates and pass them as inputs to the third template, which is then responsible for building out the rest of our infrastructure. So here it's building out some load balancers or reverse proxies, an application tier, potentially a highly available relational database tier on RDS, for example. So this is an example of reuse, and also an example of how we can start segregating different roles to different templates. A more advanced idea, perhaps, or a more flexible idea, is to not necessarily break those components out into first-class templates, but start pulling those components out into snippets of templates, okay, and then versioning those snippets of templates in different source code repositories, and leveraging the CI tool, Bamboo here again, to build the template, the fully fledged final template out of those discrete components. So the components in and of themselves aren't sufficient to instantiate anything on AWS, but the Bamboo environment is aware of how to pull those templates together, how to validate that template, and then use that to stand up our environment using CloudFormation. And so what this gives us is more granular reuse. We don't have to have first-class, well-formed templates that we reuse. We could just have something as small as a single configuration line that we might reuse across multiple templates. But we can also start pulling those template components out into different repositories and use access control on those repositories to get segregation of duties. So here we have an operations repo and an application repo. The operations repo might contain all the snippets of CloudFormation that's required to build our network and manage security in that network. The application repo, on the other hand, may contain all the template snippets that are required to configure application-level concerns on our load balancer, or perhaps bootstrap our application environment, but it can't change anything around network security, for example. Custom resources are a powerful feature that allow you to extend what CloudFormation is aware of and what it can do. So here we're representing a custom resource that is going to do a lookup in DynamoDB. Now remember, I talked about our AMI lookup table that we have in DynamoDB. This is actually how we've implemented that. So here on the left-hand side we have AWS CloudFormation as a service, and it can fire lifecycle events to an SNS topic, the Simple Notification Service topic. And in this case we're firing a create event, and we're passing a bunch of key value parameters, app, version, and OS to that topic. We then have an SQS queue that is listening to that, or is subscribed to that topic, and so that create message gets delivered to the queue. We then have the custom resource implementation subscribe to that queue and triaging those messages. So the custom resource implementation will look for the message, it will look for the type of message being created, and then it will implement what that message is encoding. So in our case, it will go off and do a create or a mutable change to DynamoDB. In this case, it could be a query to go and insert a AMI ID into a DynamoDB registry, and also look it up and return that back to CloudFormation. So this is an example process flow for how custom resources are implemented. It's not quite this complex though. We do have some code, open source code, that makes this simpler, this wiring of components together simpler, and this is the custom resource bridge that's available on GitHub. I'd encourage you to go and have a look at this if you're interested in implementing custom resources. It does simplify the triaging process for the messages in the custom resource implementation, and exposes things via environment variables to make your life easier when you're implementing the stuff. This is an example of what a custom resource looks like, though, in your template. So this is just JSON inside a CloudFormation template. And the thing that's signaling custom resource here is custom : on the type. And then we have a properties map inside of that, which has a service token. And this service token is that SNS topic. So on the previous slide where we were firing messages into a topic, that's how CloudFormation knows where to push that, those messages. Then we have inside of our properties map, we have a database changelog. And this is effectively what is passed to the custom resource. So here we have whatever schema we want to dream up, and we're passing a change set with an ID, an author, and changes array. That changes array has a create table key inside of it, and the create table snippet here just encodes things like the table name and the columns. It's a really trivial example of a single column table. And so what the custom resource would do is take this payload in the message and parse it and implement that and go and talk to the database and actually go and create that table. Okay, so one of the final topics we wanted to talk about is how we're able to start extending our CI/CD tools. So we've already talked about Bamboo being pluggable and being able to use plugins like Tasks for AWS. What we can do with that, though, is start giving Bamboo more insight into what our environment is doing on AWS. So we've used Tasks for AWS here to make our integration with DynamoDB easier and to implement something like an AMI lookup table. So there are nice ways of using these kinds of frameworks to improve what Bamboo or extend what your CI environment can do on AWS. And what we're also able to do is give our CI environment more awareness, situational awareness of our environment. Remember back to the example of traffic matching where we needed to interrogate the load balancer to work out how many servers we had behind it so that we could traffic match on our new stack. That's something you ideally want to drive from your CI environment. Okay, and having your CI environment able to interrogate your load balancers and understand which stacks it needs to talk to is a prerequisite for being able to do that kind of work. And so being able to drive that from Bamboo lets you achieve automation and lets you do that kind of work from your CI tool. I guess one of the other approaches that we're seeing more commonly in the industry is rather than baking things into an Amazon machine image, which can be admittedly quite heavy because it represents the entire virtual machine, is we just want to bundle the application change. We don't want to necessarily bundle the entire machine description and move that around. So containerization is something that we're definitely talking to customers more about, and we're doing quite a bit more with as well. And the idea here is that we're still building environments for artifacts, so we're still using the discrete environment approach, and those environments are still transient, but we're trying to achieve a more portable and standard approach for bundling the change. So one of those containerization technologies that is becoming quite prevalent is Docker. Docker is a framework for managing Linux containers, and we've supported Docker for some time in Amazon Linux and also on Elastic Beanstalk. So I'd encourage you to go and have a look at that if you're interested in Docker. But perhaps the more exciting announcement is that we have an entire container service now that supports Docker containers, which will allow you to manage a container infrastructure as a cluster and scale that for potentially large-scale deployments of Docker containers. This is supported within your VPC so that you can take advantage of all the security controls that you get inside your VPC. It also helps you manage the container lifecycle. It also lets you describe your application architecture in a language that then is able to use Docker containers, and it lets you schedule how those containers are placed in your cluster as well. So that has just been made available more recently in Oregon and Dublin, and is also available in North Virginia as well. And we're really excited to see what our customers do with this. Okay, so I won't demo Teardown, but it's an important aspect of avoiding CD sprawl, as I mentioned. That is certainly something that we could automate. In the demo that we normally provide, we show that this is a manual gate, so we don't actually tear down our environment in an automated fashion. We have a manual step that forces a human to log into the CI environment and push a button to approve that teardown process. You may, once you've built confidence in your CD pipeline and also your release approach and strategy, automate that. So we do have customers that use DNS to flip over to the new stack and then automate the teardown process of the old stack, but you may also choose to keep that a manual step. So to recap, remember the business drivers that we spoke about earlier on and we've been referencing throughout the presentation. We're trying to achieve approaches that let us experiment and reduce the risk of that experimentation. So remember we had the branching model that let our developers work in an isolated environment that de-risked concurrent in-flight work, so we weren't trampling on what other development teams were building. We also had automated test processes in place and gates that stopped the pipeline if tests didn't pass. And so what this is letting us do is encourage our developers to try ideas, to branch for an idea, experiment, do a build, have that build automated and have the tests automated and fail fast and get some feedback about that experiment. So this is hopefully improving your development team's ability to innovate. What we're also trying to do is improve the quality through that process as well. So automated tests are important and having gates and checks and balances for ensuring that the certain quality bar is met before we push out a change. And we've also spoken about logging and about having a discrete AMI for every build artifact that lets us roll back to previous versions, and other checks and balances and manual processes for, say, release or teardown. So there are ways of starting to build some governance into your continuous delivery model as well. That's all I have for you today. Thanks for listening. But before we go, I did want to remind you that tomorrow we have a Ask the AWS Solutions Architect session. This is where we'll have a bunch of architects available to answer any of your questions. This is a great opportunity for you to pick the brains of some of our smartest architects, so I'd encourage you to attend that. We also have on the same day a session where we're going to take your 5 most commonly asked questions and spend about 10 minutes talking about each of those in detail. So please come along to that and ask your questions and see if you get your questions in that list. And then finally, there are further resources for you to learn more about some of the things we've spoken about today. We have online training available via an online lab platform. We have instructor-led classes where you can go deeper with one of our trained instructors. And you can also validate that knowledge as you're gaining it through our certification process as well, which is becoming more widely recognized in the industry. So I'd encourage you to look at those as options to further your knowledge as well. Thanks very much for your time today. We'd love you to fill out the survey that was mentioned earlier. We really value your feedback. We'll be doing more of these and we want to improve them as we go. So please take the time to fill out the survey. And I hope this was of value. Thanks very much.